Hello everyone and welcome back. In this video I wanted to talk about hardwares and the configuration I have currently, and what we've used for this workshop is the AMD Threadripper 3960X with 24 cores. I don't remember the clock, but I think it's 4 gigahertz. And the one I'm currently using to record these videos is the 3970, 32 cores at 4 gigahertz, I believe, as well. So this is what we've used. Anything, or when it comes to CPU, anything that you have access to should be enough to use to create sims, as long as you have enough memory. The minimum that I recommend, 32 gigabytes. It's not going to allow you to create high-res sims, but it should be able to allow you to practice everything you need. And by that I mean you can create every single assignment and sim it, but you won't be able to push the resolution as high as we can because we have more memory, as simple as that. And it should not prevent you from creating nice sims, nice motion. You just won't be able to increase the resolution to something really, really high. And when I say really, really high, I mean something with 1000 in one axis, 1000 in close to 1000 in another axis, and 600 or something like that. So this would be super high res. Mid res is when each axis is between 400 to 600. Or let's say this is high res. Okay, it's high res. Mid res is the 300 range. This is mid res. And then low res would be anything less than 300, like 250 by 250 by 250. And you should not feel limited or anything by using whatever resolution you can achieve. The techniques are still the same, the workflow is still the same, the practice is still the same. The other thing that you have to account for is when you create a high-res sim, regardless of, when you create a sim, expect 100 megabytes per frame. Okay, so if you're gonna save 200 frames, that's 2 gigabytes. Just account for this ratio, 100 megabytes per frame minimum. It can go up to 600 if we start adding a lot of fields in the velocity field. Now, you don't need these CPUs. You don't have to have these CPUs. A simple explanation is the more cores you have at a higher frequency, the better. But there is a threshold where it starts flattening. So for example, this 32 cores, 2 cores at 4 gigahertz. Okay, I'm gonna do the math. So 32 multiplied by 4, 128 gigahertz. If I get a 64 cores at 3.5 gigahertz, it's almost 2 times more frequency, and it's 2 times more cores. So the sim will be 4 hours, let's say here. It's not going to be 2 hours here. It will be maybe 3 hours and 20 minutes. Okay, so it starts tapering off. The same thing between these two, the 24 cores and 24 cores multiplied by 4.2 gigahertz. Okay, let's so 24 multiplied by 24 multiplied by 4.2, it's 100 gigahertz. The sim time is going to be 4 hours and 30 minutes. It's not going to be majorly different. Okay, and these are just example. More cores does not mean faster sims. If you have access to 4-core CPU with dual threads, even like an old i7 from 10 years ago, and it has 4 to 5 gigahertz, you are able to get a lot of sims done. Okay, in fact, a lot of the old work that we did was using 6 to 8 cores i7 with 3 to 4.5 gigahertz per core. Okay, so you can get a lot of stuff done with and with 32 gigabytes memory. Having 64 is a really good range. 64 gigabytes of memory is great. Another thing to factor in is another thing to factor in, I lost my train of thought. Yes, so another thing to factor in is the operating system, whether you're using Windows or Linux. On average, there is 20% less memory usage on Linux. So if you have 64 or 32 gigabytes, you will get way more usage out of it compared to Windows, because Windows has a lot of extra things that it needs to carry. Linux, it can run on 800 megabytes. That's it. Everything else will be used for Houdini. The next hurdle is to do viewport capture. And as you guys saw, I've hit the 2.5 gigabytes on Houdini very quickly. I'm gonna open NVIDIA SMI again. This is a command line I use to check. So right now I'm at 6 and Houdini is using 2.5. Okay, you don't have to display volumes at high resolution. You can just rely on Mantra or on the render to see the final result, and you can do a still frame. Just put the volume, hit render, or use a pre-built in from the shelf, and you should be able to get a viewport capture. 2 gigabytes of memory is a bit limiting. 4 gigabytes will be good. 4 gigabytes you can get some stuff. So you don't need a 2080 Ti. You don't need a 2080 or anything. Even those like 960, 970, and the old cards, even 880, as long as it has enough memory, it should work perfectly fine. When it comes to more professional work, if you're going to be doing serious work, then having like a dual Xeon or an AMD Threadripper would be the way to go, but it is not required for experimenting and learning everything about Houdini. Okay, I think that's pretty much it for the hardware. Just I'll share more in the assignment video about the guidance and how I want you guys to work and what needs to be done. Thank you for watching, and see you in the next video. Bye bye.